Besides being a brilliant mathematician and an artistic woodturner, he's a dentist somewhere in that mess. I'm not sure where, but and a birder and a beekeeper. Sounds like Peter Sellers' movie. He's marvelous. So I'm going to let him get rolling. He's going to do self-explanatory sphere and then into one of his forms, ice, whatever. You can tell I'm not a mathematician. I'm just a, you know.
So this one's going to be an octahedron, so that's okay.
This one's going to be an octahedron.
Yeah.
There we are.
Yeah.
Okay.
Okay. Is this? Can you hear it with this? I can't tell. Okay. Pass those around. So I've always done spheres this way. You can do it. So this is a shadow method, and anybody done the shadow method for making a sphere? Chris. Okay. So shadow method is really basically turning a block of wood close to a sphere and then using a chalk and removing only the portions that are high, basically. And you'll see what I'm talking about as I do it here. You can actually kind of get there without doing what's on the handout, but the handout just makes it easier. So there is a little bit of math involved, sorry. but you can always have one of these. I always have one of these sitting around my lathe, a calculator, and it's easy enough to use. So there's a tiny, like I said, a tiny bit of math on here, but it's not much. So this I actually swiped off the internet, and I know the guy that put this together. Oh, this was ages ago. This was probably a decade ago when I got this off the internet. And he's not going to care if he wants everybody to use this. So I just printed it out, and rather than redo it, I just used what he did, because that's how I do it. And I actually keep that thing sitting on my table in my lathe in my shop, just because I refer to it all the time, because I can never quite remember, the math involved. I believe it's 0.41, isn't there, on the sheet? 0.41 of the diameter. Yeah. And then after that, it's just dividing things in half. So basically what you're doing is you're starting out with a chunk of wood that's a cylinder. And I've already laid it out and everything, and kind of gotten myself to the point where so I can turn it fairly quickly and get to doing the octahedron after I get the sphere. But you start out with a known diameter cylinder, and then you size the cylinder to the same to the diameter. So that's the sides here, but you still have tenons on here. And I actually, what I was just doing is there's two more sizing that you're going to do. So this diameter right here and right here is actually the 0.41 that's on your sheet. It's 0.41 of the total diameter. And what we're gonna do is we're gonna cut off. So, and then I mark the center line. So you measure this from side to side, and then you mark the center line. And then you use the same dimension, 0.41 of the diameter, and divide that in half, and make lines on either side of the center line. And what you're going to do is actually just cut off the wood from here to this diameter. And then you're going to divide those in half, and you'll see, and you actually end up with an octahedron. Well, not an octahedron, an eight-sided round figure. So basically, it's like a stop sign if you cut it in half. So we'll just go ahead and do. Should have sized this before. Just twist. Push. Oh. There we go. All right. Can you hear me still? Okay. So, like I said, I've already measured the diameters, and you see that on the paper. So this is 0.41 of the diameter, and then each of these lines are centered at 0.41 of the diameter out over the center line. And you just take a flat cut from this to this, and then cut that in half. So we'll go ahead and do that. I use a gouge for all of this. And once we get to making the sphere itself, the wood is going in all different directions, and I still use just the gouge. This is a fairly wet piece of rock maple. The tree that was in our front yard that I took down last fall, but it's been end sealed and sitting around in my basement of my shop, so it's still pretty wet. So you don't have to be perfect with this, because the shadow method is going to get us closer to perfect. You can get anal about it and make sure it's flat by putting a straight, and it's actually pretty flat. But then that distance should be very close to the 0.41 of the diameter. If I remember, that was 59 centimeters. And I'm just a little over that. It's okay. Like I said, this is just getting as close to a circle, because the shadow method is what's going to make it a true sphere. And I don't know if you saw that, but I just switched hands. It's because I didn't want to get pelted by wood, and I do that all the time. I don't even think about it. It's just if I can go either direction, and I'll do that all the time. So that's pretty good. It's the end grain is going through the blank this way right now. This actually got, what's that? Yeah, probably. I guess I would do that as pretty much as a matter of course. So this is like right on the measurement that it was supposed to be. What's that? No. There's not going to be any chuck involved in this. Yeah, there won't be any. There's no chucks involved. It's all between centers, and then so now what I'm doing is if you see on the paper, you got to divide this in half, and then divide each of those in half, because what you're going to do is then make the next cuts. Let's see. I guess I have to use millimeters. So what I'm just making the center point of each of these surfaces, and I already while everybody was getting here, I cut this second tenon here to the half of this diameter. So I've already got that figured out. And you don't have to do this. It's just, it gets you to the, you'll see how easy it is to get to close to round by doing it this way. It's a bowl gouge. All right. Okay, so I've got them all marked out. This tenon was proud of the actual surface of the. So this is, yeah, it's hard to show, but this right here is actually the measurement for the sphere. So I've got to remove a little bit of wood there to get me down to the tenon. Then I'm just going to go ahead and do the next step, which is to cut off this corner. It's taking it from that center line down to yeah. So I'm just going right through this real quick, and so I'm going to just cut off this corner from this line to this line. Oh, I shouldn't do that. I'm so used to doing that. Not supposed to move the tool rest when you have the lathe on. I do it all the time. I'm so bad. Okay. Oh, wanted to skate on me. I think there's some wild green in this that's just causing that to bounce. Okay. This had a bit of figure. This maple had some figure in it, and I think I was hitting some of that. There's also a bit of a bark inclusion on this side. Okay, so at this point you have an 8-sided round figure, and what I'll do at this point is I'll use a bit of a shear cut. So I'm holding the tool, so I'm using this edge and I'm drawing it, and I'll just take off the corners a bit and just make it by eye into what looks close to be a sphere. And I constantly move the tool rest. This one's a bit long for this, but it's all right. What'd you say? So now I'm going against the grain. It's, you know, I'm going uphill, but I don't care at this point. It's cutting. It's doing what I want. There's going to be tear out because of the process of when you actually cut the sphere. You're going to go in all different directions because you're moving the piece of wood constantly in the chuck in the jam chuck, and I'll show that to you in a second. So I'm going to just get it close to being off. And usually, Chris, do you have a saw? I'll just cut these ends off, and that's what I usually do at home too. I don't, you know, a lot of people, turners, get real picky about cutting it off the lathe with a parting tool or something. I always use a saw. Yeah, it's perfect. I don't know. I have no qualms about that. It's just like what, you know, I think actually thinks it's safer and things don't go flying and. At this point too, you can actually, and I think it says in the handout, you can actually mount it in the cups, the cup between cup centers, and turn these nubs off. I usually cut them off. Just a smaller gouge, it'll get in there a little tighter. That is a prong center, and I just don't want to hit it with the tool. Okay. So it's pretty close to a sphere now, but it's not a sphere. And you'll see that. Guess I left a little more meat on this side. So I've done enough of these forms But I have laying around in my shop tons of these pieces of wood that I've mounted and used for whatever size sphere I'm turning. And it's mostly because of this last series I was doing. They all started out, mostly all started out as a sphere, and they were in different sizes. So and I just keep the pieces of wood and repurpose it. You know, I make them fit whatever I'm doing, and it will make this one fit. Right now, so it's just scrap wood that I've had laying around, and I just leave it on a faceplate and sitting around. So it should be fairly true, but I'm going to make it just make sure it's true, just because the wood could have moved a little bit on me. I suspect not, because this one's pretty dry. Oh, that's fine. I don't need to return that. Often I'll return it. I'll often use a piece of wet wood, and that will move on me, but that one's fine. So what I usually do, so then my little trick that I told you about, it works. So this is Robo's tailstock, and it's very similar to the one way, but you don't need that little bar to hold it, because it's designed a little differently than the one way. So what I usually do is I'll start out where I've cut off the tenons, because that's going to be proud, almost for sure. This is a little big. I didn't bring a smaller one. I like to have, so I usually start out with a smaller jam chuck for something like this, but I'm going to repurpose this jam chuck to fit this sphere for the next part of the demo. But I would usually, if I was just doing a sphere, have a piece of wood on the other end that's about the same size. But this will work. So we're close, but it's just, it's not going to be perfect. You hear the little bit of wobble. That's just the wood talking to each other, the two pieces of wood. And the shadow method now is really not really a shadow. It's the outline of the proud wood that you're just taking off just the amount of wood that's proud of being round. And you almost always use just a shear scrape, basically, kind of a shear cut, shear scrape to do this. And like I said, now you're really, I'm cutting end grain and side grain on this, but it's going to vary because I'm going to do a whole bunch of axes on this before it's round. Once it starts feeling, and I go by feel, I'm watching up here, and as you've probably all heard before, you really shouldn't be watching the tool. You're watching the wood. And I'm watching over here where I can see the shadow going away, that faint outline of the wood that's proud. But I'm also really going by feel. Once I'm pretty good and I'm not bouncing, I'm going to stop and I'm going to change the axis. So that's close. It's not, I mean, I could make it closer, but changing the axis is going to make things out around again. And so I don't get too anal at making it perfectly round at this point. I'm going to keep changing the axis until it gets closer. So, what's that? Yep, totally random. I tend to choose. I can sometimes tell where the high spots are, and that's where I want to cut. So I'll try and orient it so that's what I'm cutting. So I'm trying to use, I'm not forcing the tool into the wood, and I'm just trying to get off the high spots. I'm not trying to get down to solid wood. I'm just trying to remove just the high proud spots. Yeah, where am I? God, you got away from me there. That's a nice little spiral circle cut. If anybody's familiar with Hannes's signature cut at the end of his hat demo, that's what that was. Yeah, yeah, yeah. And sometimes, like right now, it's bumping a lot, and you think, well, you know, you're taking a ton of wood off, but you're really not. And um, sometimes as you're doing this and you're changing the orientation of it, you don't think you're going to get there. You think you're going to end up with a ball this big, you know, but you really don't. Everybody asks about speed numbers. I don't have one of those on my lathe. I just go by what feels right. Yeah, you can hear it now. It's really getting pretty true on this axis, but it's probably still not there. Yeah, I can feel a bump right there. I'll change it to that. And you know, I don't get, I just kind of get it close, and you keep doing this, and that's why I'm saying you're cutting on every possible direction on this when you're doing this, because you're changing the orientation constantly. But that's what makes it a sphere. That's the whole. Sometimes if it's just a bit out of whack, I'll whack it like that, and it is what it is, I guess. As you get close to the tip, the smaller diameter, there's less really there that you need to remove. So yeah, I take it gentler up here, because it's you're not needing to. It's not as far out of round as you get us to that smaller diameter. Keep wanting to hit my switch. It's always right here for me. Robust. Yeah. Yeah, that's getting closer. It's still a little bit going to be a little bit of a bump here, but it's starting to get there. And to be honest with you, on these forms that I'm doing, I don't have to have it perfect. It's close, but and I usually get it real close. Using this method, you can take it all the way and just keep doing it, and then once it's close, real close by just with the gouge, and just use sandpaper in a disc, and you'll get it that much further. But keep doing the same things, keep rotating the axes, and you'll end up with a nice. This side is not for sure. This side is actually pretty close to that, but it's not intentional. It doesn't have to. You just need to have them both be true. They both need to be running true, so that your sphere is always running true, and it'll the one thing you don't want is that the curvature of your cup centers is convex of the sphere itself, because then you're not actually grasp. It's not going to hold it and help it run true. So it's got to be dished out enough that you're at least hitting the edges of it. And even with that, even with its being, that what I just said, that you've got basically the rims of the pieces that you're holding it by, I still end up bumping it, and it seems to often get it to run a little truer, and I don't know why. It doesn't make sense to me. It shouldn't do that.
And you can see I'm taking less and less off each time as I switch the axis because I'm getting close. Part of that is also that I can't get into closer to the tailstock on that side because my chuck is too big. So I'm having to turn it more than I normally would. So you can see, I mean, I barely had to take off any right there. That's good. I mean, I could go further, but there's no reason to. Did you see? I don't know if you could see that, but it's running almost perfectly true right now. Just a tiny bit of shadow, but hardly enough to really care about. Do one more axis just for fun. Did you hear that? Did you see that? Just bumping it did that. Okay. I'm going to call that good. I just want to check it. So, we got a sphere. And it's pretty close to a sphere. There's really not much left to do it. I mean, if you sanded that, it'd be a nice sphere. It's not going to stay together because I already had a check in it when I started, and like I said, it's wet, so it's going to crack for sure. So I cheated for this demo's purposes because the next thing what I'm going to do is turn a sphere into tetrahedron or octahedron. So an octahedron, each one of those octahedrons, the points of that octahedron, and there's 6 of them, all lie on the surface of the sphere, and that's all that's left of the sphere is the points. And each of the faces is, there are 8 faces. That's where it gets its name. There are equilateral triangles, so that means they each intersect 3 points. And so then to do an octahedron, you've got to lay it out. and to do it the way I do it. So the first thing I'm going to do is I'm going to get this chuck, the jam chuck, to fit closer to actually fitting this in. So I'm going to actually modify that so that it fits the sphere pretty well, because it's going to be crucial to be fairly close as I lose wood as I turn the faces here. And I cheated on this one because I knew one of the issues that you end up, for laying this out, you've got to do you've got to find the center line, and you got to know where the apex and you've got to be able to lay it out in two different directions. You got to have the one axis, like the top and the bottom. And I've already got those points. Before I started turning, as I got this blank prepared last night, I marked those by just making a small, drilled a small hole in each end, right at the very, and that was what my centers were on when I first turned the piece between centers, were on those holes, so that I had those points as known references. So that's one of the things you have to do in laying this out. And once it's a sphere, if you don't have those references, it becomes difficult to figure out, am I exactly right, on the polar ends of the sphere? That I'm sure I haven't thought of a way to do it. Probably if you put a pencil on a table, and I don't know, I'd have to think about that one. There's got to be a way to do it, but I haven't tried it. Yeah. Right. Yeah, that's what we're going to do here. That's what I'm going to do. Yeah, yeah. But getting those polar points those are key to this form. You got to have those, because if you get to a sphere and you don't have those, then you got to figure out how the heck am I going to mark those 2 points? Because that's the starting point for it. So I'm going to turn the chuck here to fit. Yeah, I don't know how close I am here. I guess, where did I put that? Put it in the trash. Okay. Still reaching for my controls down here. Not going to happen. And amazingly enough, I guess I've done this so many times. Oh, I want this surface to match this surface better. So it was just being held by the rim. And I need this to actually fit the surfaces, and you'll see why in a minute when I start turning this. So I need that to fit a little better. What's moving? Now this doesn't have to be perfect, and I never get it perfect, but it needs to be pretty close. That's I'm getting approaching what I want. So this is not your typical bowler orientation on this jam chuck. It's end grain that I'm cutting. But I guess lately the majority of what I do is end grain like that. So that's close. So that's fitting pretty good. So I'm good with that. So spindle lock. This one. And I think I didn't bring my I need a big wrench. Is that gonna fit my faceplate? Yeah. No. Oh, it did. Wait a minute. It does. It fits. Awesome. That was good. Can I do reverse on this? Not supposed to do this. I do it all the time. All right. Okay, so what Chris was talking about is what I'm going to do now. Is you got to lay this out. And I'm going to just do it by eye. It's very similar to what he just said. So I'm going to put it between centers on those previously defined centers. And then you can get, and I do, of course, you can do the math and figure the next part out. But I figured out an easy way to do this particular form when Chris was asking how I did it, and I figured out, oh, you can do this easier by kind of trial and error, and it works fine. But you can't do it for all the forms that I've done. But for this one, you can get away with it. So I'm going to call that the equator. And it's still bumping a little bit, but that's okay. So that's why the line wasn't completely around. It wasn't completely around there. So, but now, when I do forms like that, each face is turned on a center between the chuck that I just made and points. And there's 4 points. So is this have indexing? Hopefully. And then you index it in one of those holes. Okay. Okay. So but while he's doing that, let me, the next part, and this is the part where it's a bit of trial and error, is you got to find out where, so there's 4 faces, and we're gonna draw lines for, and that'll give us the center lines for each of these faces that we're going to turn. And we're going to turn the faces so that these are equilateral triangles. So each point of the triangle will fit on, it will come to the surface of the sphere and be equidistant from the center that we're going to turn, that we're going to find. So
depending on which one you put it in, you get different angles. You're trying to just go full quadrants.
I'm going to do quadrants. Yeah, just 4. Yeah. Okay.
Not exactly.
Okay. Yeah, it'll do the trick. So what I do, what I figured out for Chris is that you can draw a circle, and it will get you really close to this, doing it mathematically. It does the same thing as doing it mathematically. So the circle needs to, you need to be able to hit the equator and the top, and then you'll be actually equidistant from all 4, those 3 points. So I was a little bit large there. And this is a bit of trial and error to actually get it so that it's right. And I'm just guessing here. Actually, I need the 4 points. That's what it was. Yeah, I knew there was something up. Yeah, I do need the 4 lines. Because it's got to hit those, the equator at those points. So this is, okay. So, and here's where I would use something like, where's that jig? Yeah, let's try that. It might work. Oh, there you go. Awesome. Yeah, I've made one of these as well. Although mine, I can rotate. Yeah, it's good. Awesome. Well, let's see if I can get things out of the way to do it.
You know what I did? I just turned it between centers, put the centers on the equator, did another one of those.
Oh yeah, you could do that.
It
Does the same thing.
That jig, but that jig certainly makes it easier.
Yeah.
All you need is where it touches, right?
Yeah. Yeah, you could do it either way, but so this jig is made so that the center line is at this at the center line of the spindle. So it should be right around here. Yep. So yeah, we'll just do these points at this point. That'll get us. Okay. You actually don't have to do all 4 points if you've got two known points, because what we're going to do next. So now you've defined 3 points, and you just have to find a circle that fits those 3 points. Yep. Yep. And I have even bigger compasses than this. So that's pretty good. It's not perfect, but for this purposes of this show, it's good. So I just drew, you're going to see why I did that. So I've got to do the same thing on the other side. The other hemisphere. Well, you could measure it. Yeah, I'm not measuring it. I'm just going by. Well, your compass is good. Yeah. Yeah. Okay. Where is the camera? Is this good? Okay. Now, can you see what I've done? This diameter, the compass moved just a bit, but I'm pretty close here. Okay. All right. Where's my point? It's a little point. So I just circled those just so that I can actually. I'm attached. Okay. So what we just defined there was where each of the 4 center points are going to be. Yeah. Yeah. So I didn't tell you that trick. Sorry. Okay. So now I'm going to go back and do the same trick I did before, just to define my points. Let's see. This tool rest is just in the way. I could, but that's all right. So actually what I'm going to do is do this. Should have thought of that earlier. No, they're not necessarily the same. It doesn't matter at this point. Not the same index. It wasn't in the same point. But these are going to be the centers of the faces. What I've marked now. The others were just to find where this line goes, and you can do that mathematically. But I thought this was a much better way for folks here to do it. Okay. Now we should be good. Is there a Sharpie somewhere here? Okay, so I'm just gonna mark those spots so I don't get confused with those other lines that are on there. And I do that all the time. Sharpies are my friend, and I have different colors Sharpies because I will color when I do the piece that had 32 faces, and some were hexagons and some were pentagons. I would keep it all. You got to keep things so that you know what's what. So I got 4 there. They're going to be the centers. Yep. Yep. Of equilateral triangle faces. Yep. Okay. So we're laid out. Those are the points, and that's all we need to know. The other thing that is good to have is the lines on here, and you'll see why. As I turn these, I turn the faces until the faces are lining up with the equator and the poles of the sphere. All right. And so now it's really between centers. This is pretty safe. I've never felt uncomfortable at all doing these. And some of my work can become uncomfortable. Some of the minimal surface stuff I've done has been pretty wonky. This is not at all. Doesn't matter which face you decide to start with. Oh, you know what? I need. Do you have a center, just a all or it's a point, a punch? Yeah, I just like to. Doesn't matter. That's good. That'll work. Just to define the. What Chris turned and the other pieces that I have over there, take this a notch up and make it that much more complicated because they're boxes, and boxes have an internal sphere, and you can do like Chris did and just make sure that you make the sphere small enough to fit and just kind of go by kind of your gut instinct. It's actually smaller than you think. The sphere has got to be small enough that you could easily, if you overdo it and make a bigger sphere than will fit inside. But there is a mathematical formula that you can use to actually determine how big of the sphere will fit within an octahedron. And I use that. Yes, I do. And then you got to have wall thickness. Yeah, so you got to take all of those. So if you see what Chris has got and feel the faces, it's right in the center of those triangular faces where it's the thinnest. And that's right at the point that I just really close. Yeah. Okay, here we go. Okay. So what we're going to do, what I'm going to do is I'm going to cut until I'm really close to the pole and the equator, and you'll see that as I turn this. And it's not a perfect sphere. It should have been a little closer to that, but it's okay. And again, this is all different orientations. You're not really going to be able to cut downhill with this. Make sure you're sharp. And now you can see this, what the size. I think Chris was surprised. You start out with this huge sphere. You turn away most of this wood. You're really not left with much after you're done. So you think you've got a big form going, and it's not so big once you're done. So I'm stopping just to see where I am compared to that pole, and starting to cross the axis. It actually becomes even more apparent once I turn the next face, because then we'll start defining the actual form, and you'll start seeing it. Okay, I didn't actually mark out the lines of the center lines between the axes. As they cross the equator, that's a point. Okay, so, and I didn't actually mark those out because I've got the pole. So if can you see the pole? I don't know if that's on the camera. Is that better? It's right. Yeah, it's right here. Can you see that? So I'm cutting the face in so that once my circle, the face that I'm cutting, it gets almost right at that pole, I'm done. I can't. I have to stop. Yeah, you could. I don't. I've never done it. Yeah, they would all go away. I mean, that's not an issue. You did? Yeah. It was the points. Yeah. 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 So you could do that. We could do that just for fun here. I've never done it. I just turn it, and I just kind of am careful as I'm turning so that I know where I'm at. Like I said, they'll all go away anyway. So as you're turning, because you're gonna turn most of this wood away. I tend to take heavy cuts, and when it's getting the short grain running into the gouge, it's a harder cut for the wood. So even with the mark, I'm going to stop and see where I am, because it's really better to do it. I can't even find the pole. There it is. Okay, so we're close. And so the other thing with the boxes, I'm making just a bit of a dish here. So I'm hollowing it out just a bit. And what I would do if I'm really wanting to be accurate about this, and I do when I'm making the mathematical forms, I want them mathematical. I will actually, I'm not going to do it today, but I'll actually measure the length of this tenon, so that if I'm dishing it out, I want them all dished out the same amount. So it might be a 1/4 inch dish that I'm making, but the way I determine that is by the length of the tenon that I'm leaving behind. Now you're seeing what we're after, yeah. Just a little bit more. So at this point, I leave this much mass in the tenon, and that may not seem like a lot, but it's, for me, a lot. Because it's actually going to be supporting the piece as I turn around on other axes, and I need that extra support for the other axes as I turn them, because it's going to be inside my jam chuck here. Yeah, so the first one's easy because you're turning solid wood. Now you're starting to turn air, and it gets more and more air as you go, and you just gotta turn, and you're not jamming the tool into the wood. You're letting it come around and come to the tool. Here, let's do this again. Just for the sake of people that want to see, for those that are curious. Not much of a line now. This wood really is grabbing me. Not sure why. It's pretty standard bolt cut, I would say. It's about 45 degrees. Can you see it now? Yeah, I've got harnesses grind. No, no. I'm doing a standard bolt cut. Yeah, it's going to be. I'm just leaving a little bit proud of the point. This face was a little proud of the point. I'm going to take one more. Just get a little closer here. That's better. This side. I'll take one more cut on this side too. See, and that's the nice thing about this is I will turn these faces, and it's what I was saying. I leave the tenons beefier because I'll go back after I'm done getting all the faces turned and thin those down, so I don't have to. I'll actually end up just cutting those off. I use carving tools to cut those off, the tenons off, and then sand it smooth, or whatever I do to it. Yes, I could take one more cut there, but I'll go on. So you just keep going around, and you're gonna, this time,
Mike, you thought that having that huge compression shot keeps it more centered than just put it centered to a small drive center? Because you've got the, you're going to keep those knobs on both sides all the time. You could just put it.
yes. No, it actually gives it more drive,
Yeah,
and
get a little tiny drive.
right. No,
I did, but I was thinking
yeah. So each of these,
they could cross.
well, they could if you're relying on those. And once you get to some of my other forms, you're not always directly opposite, polar opposite with those points. Whereas here they would be, and I didn't think of that. I've always done it in a jam chuck like this. But yeah, you probably could do that with this form.
That's pretty cool. Particularly if you start getting rain across.
Yes, and that's the problem is that these are not yeah, it can definitely be totally cross grain and they'd be really weak. Yeah. Oh, do you want me to mark that? Like I said, there's not much to mark anymore. Less and less. No. Sometimes when I'm doing the more complicated forms, I try and balance it out so it's a little, and so I keep it balanced in the chuck because you're losing mass on one side or the other. But you're really held well by I've got at least 4 points in here holding it, and between the centers, it's really pretty stable. It's just moving a little bit in the chuck, and that's okay. Just right here. And that jam chuck may not be completely true, so it's moving a little bit in that. It's not matching the exterior of the form real perfectly. You can see I'm pretty comfortable turning air, and I've done this so much that that's just second nature to me. I don't even think about that. Whereas I'm sure that, as this wood is coming around, for inexperienced people that are not used to that, it's be real easy to get your gouge in too far and this comes around and wants to knock it. But I don't ever really do that, and I never really have an issue with that. Need just a little bit more there. But some of the pieces I've done of the other kinds of forms that I've done, like the minimal surfaces, are far wonkier than this. And it's like I said before, you just have to be patient and let the wood come around to the tool. Just another cut. Here's where it becomes more like the shadow method of the sphere. Is you're really, I can see right through my form here if I'm looking at it in the right direction. Because I'm turning a lot of air there. Okay, that's good. Good. All right, we'll make one point here. So now we got very little wood left. So that's all the wood I'm going to be cutting. It's just one tiny bit of it there. This is fine. As long as it's not rocking on me, I'm good. All right. That's 1 point. So now you can see where those tenons I left behind become important. Yeah. Yeah. And that one is actually believe it or not, that one is a trickier form. Yeah, that one's not as easy. And actually, the piece of wood I started with, the one that's in there, was even worse because I was trying to maximize it. So I really had to do some math to figure that one out. Because I wasn't starting with the sphere on that one. Oh, I forget. I never mark them, so, but I'll mark it. So here now we've already gotten some of the faces turned because they're meeting up with the top. Yeah, and Chris, the other thing I was thinking about, the reason why I don't do that, well, one is because of the tenons, but I always feel that I'm more centered, and even though because my measurements could be off, but I'm still centered on. Right, right, right. Yeah, there's less wood now holding it and driving it. So it's wanting to spin a little bit on me. And that's partly a function, it's probably not fitting the exterior of the sphere real well. Getting close. And I always tackle the base of these tenons, just like you saw me just doing. I come at it from both sides. And you can get it so that it's a straight tenon right into the form. But you can't cut it from both, you have to cut it from both directions. So if I went right up to that, the flute edge would catch and things would go flying. So I get close like that and then come up from the other end. Awesome, that's good. You want the line? I'll put the line on. Not much of a line anymore. Who was it that was talking about the two friction coefficients? I'm relying on one of those, and it's not doing so well for me. It was you. Yeah, and as I get closer to the final cut, then I'll slow down. You know, I'm taking pretty heavy cuts, but I'll slow down and take lighter cuts so that I have a cleaner cut. That's good. It's the math involved. Yeah, it's really hard to grasp until you do it, but it's really kind of does it itself. Right now, it's actually just the other center. I didn't get that. Well, no, there's three. There's yeah, no, there is.
Big enough around our
Yeah,
stretch,
yeah,
not just the lowest.
yeah. A couple of the others around. Yeah. Yeah, this face wants to catch a little more on me. And I'm taking pretty heavy cuts just so I can get it done. Okay, one more face. So the boxes are a bit more of a trick as well. So the first thing you got to do is make your internal sphere and make a box. And you've got to factor in the tenon in that, so it starts out as a little bigger than a box. So I always make the internal sphere first, and I do make a sphere. So that means you have to factor in the tenon and the mortise, and you have to figure out where that's going to lie. And you actually want the join coming out on the equator, because that's how I don't mark the equator, because that becomes my equator, is the join in the box. And then you join it after the internal box is turned, you join it together. You glue it together, use hot melt glue. That's the trick. Because hot melt glue will hold, but you got to get it tight, so you got to be quick, really quick. You got to get the hot melt on there. Yeah, and you got to get it lined up, and you got to get it glued together. And then once it's glued together, it'll hold for you, and you'll be able to turn the form. But then you turn the sphere with keeping that join of the box on the equator. So this equator. And then you take it, after the form is finally turned, then you can take it apart by using either acetone or I just use alcohol. Denature alcohol works, and you just pour it on there and it debonds it. It's amazing.
Or you take it off the lathe and it's already
Now here I don't have a line, and I'm to the point where I really need the light, so I'm using the shadow method to know where I'm starting. I think I've still got quite a bit to go here. Yeah. Yeah, something got off a little bit on me there. I'm not sure what exactly it was. It's probably the jig's not 100%, so the points aren't exactly lined up. It should be pretty close. Yeah, so this point didn't come out right. Just like I said, it was something was off in the jig probably. So, right, it probably got skewed at one point, one way or another, and I kind of knew that as I started turning this face, because it should have been pretty equal, the amount of wood on each of the points that I had, and it was uneven, so I knew that it was probably going to be off. There you go. So, like I said, what I would do at this point is I would remount it on all the centers and take these tenons down to maybe 1/4 to 3/8 of an inch. Not much, nothing smaller than that. Again, you know, you're talking about cross grain, and if you get it too much, it's going to fly on you. You don't want it to fly on you. So cut them off. Yep, and I don't cut them off with a saw at that point. I use rotary tool. I have all the rotary carving tools, and I use that. And then I have small sandpaper discs that I have any number of sandpaper discs. I've got them down to 3/16 of an inch sandpaper discs, similar to what somebody was talking about in the. I've got those, but I've got 1-inch discs. Probably around 3 o'clock. Yeah, yeah. No, it's already hollowed before I do this. Well, no, it's turned as a box. So I start out as a large cylinder. Okay, so I have a big cylinder, and I know what size internal sphere I want. So I then actually use templates, circle templates that I cut out of a piece of a cereal box. I use cereal boxes all the time for that because it's stiff enough and you can cut it easily. And so I'll use that as a guide to get my internal sphere. So I get real close just doing it by eye now. I can pretty much cut a sphere almost by eye, an internal sphere. But I'll use that to size it because I need to get it to the right exact size I need. But like I said, you've got to factor in the tenon, and so because if you don't, then you have a squashed sphere. But that's okay. I mean, most people wouldn't notice that, and it would actually only make the amount of wood in the thin part a little bit bigger, and that's always good, leaving you, and so you're not going to go through the side. Well, it's got a tenon, so you know that, and then yeah, you glue the blocks together with the hot melt glue, and then you turn the sphere like I did here, using the equator, the joint of the box as the equator, and the two polar points. And then you actually have already some of this defined for you as you're laying it out.
One thing that helps me sand, knock all this off. Sand, and hard to hold on to. Certainly not going to sand it on the lathe. So what I did was I took jam chuck, put a sandpaper disc on it, that in my lathe, spun that pretty slowly, like 200, and held onto it by hand and went in, and it actually really worked well. I had the light going right down on it, so I could kind of shape it. I could look above or below the original split, I can see it a little more off one side or off the other. You're probably just doing a real rotary tool, right?
Yeah, I in my Fordham has a handheld 2-inch disc, and I can do that just sitting at my carving station. And nope, I people use those, but I have never used one, and I still don't. And I do tons of carving on my work.
Back to the wall thing. The other thing you have to realize, whatever wall thing you have here, is also the wall thing you have right here where your pen is.
Right.
So, get any thinner than I did, blow that out.
Yeah. Yeah.
Kind of lucky, I did.
Yeah. Yeah. Sure. More than happy.
No, but I would challenge